Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ritika welcoming you to Grade 11 Elite Math Term 1 session. Today we are going to be completing Lesson 1-2 Vectors in the Coordinate Plane. So this video is part 2 of the session, and in today's session our learning objective would be to solve some important vector problems from your textbook. So it's a must watch video for all my dear students of Grade 11 Elite. Watch the video till the end because in the end we are going to be doing some problems from the textbook. This session is pretty important. We'll look around word problems as well. So stay glued, and if you have not yet subscribed to the channel, a humble reminder, a kind request to do the same, and also press the bell icon so that you don't miss upcoming videos. So let's dive into the video and see what we're learning today. So our lesson menu consists of the vocabulary words which you have already seen. We'll also be looking at more and more applied vector operations and problems. So you look into real world examples, you look into word problems, you'll get to know about component form and direction angles of vectors. And as I said, towards the end you have an important textbook problem coming up. So let's dive into the video and start today's important session. The first example that we are starting today is on component form. So find the component form of the vector v with the magnitude 7 and direction angle 60. So if you see here, both the magnitude and direction are given. So you can find the horizontal and vertical components. So you will use the component form of the vector. If you recall, then we can find the component form by the x component using cos trigonometry, and the vertical component using sine, the vertical trigonometry. So absolute value of v, that is the magnitude of v cos theta. I'm just going to highlight. So this is magnitude of v cos theta, magnitude of v sine theta. This is the component form. So just plug in the values. Magnitude is given 7, angle is given 60. So you will use your calculator, you'll use your trigonometry to get sine 60 and cos 60. Plug in those values. They are 1 by 2 and square root 3 by 2 respectively. Simplify and you will get your component form of the vector with the magnitude 7 and direction angle 60. Very simple. The important thing to remember would be this formula, where you have used the component form of the vector and resolved the vector along the horizontal and vertical components. You can also check your answer by drawing the graph. So if you see, we have got the vector along the horizontal and vertical components as this. Let's resolve it and convert it into decimal form. So this is the value. You put on the coordinate plane x as 7 by 2, y as 7 square root 3 by 2. So this is the vector you are getting. It is at an angle 60, as you see with the positive x-axis given in the question. So find its magnitude. First of all, magnitude is coming 7. If you check the angle by using your protractor, then the angle would also come out to be 60. That means you have resolved the vector of the magnitude 7 along the direction of 60 degrees along the positive x-axis. So you get this vector. So your answer is completely correct. Well done. Now I want you to try a question yourself. I'm going to be giving you a few minutes for trying this. If you see the question carefully, it's a multiple choice question, and when you solve it, you will get the answer as B. So look into the steps. Magnitude is given to you, angle is given. So you will use absolute value cos theta for the x component, absolute value sine theta for the y component. These are the components. So this is going to be 12 cos, let's just plug in the values, 300, 12 sine 300. Now you need to use your calculator, you need to use trigonometry, and you need to get the value of cos 300 and sine 300 respectively. So the value that will come out here would be, for cos it is 0.5 in decimal form. For sine, let's do it. So sine of 300, that's what we need. So it will come out to be a negative value, which is negative 0.866 in decimal form. So you can just convert this, or if you don't want in decimal form, you can also put it in radical form. So this is 6 comma minus Let's find this multiplied with 12. So in decimal form, it is negative 10 comma 10.392. If you want to convert in radical form, it will be negative 6 square root of 3. So your answer is definitely B, and that's your correct answer for this question. Well done if you got the C. Next question that we'll be solving today, example 7, would be based on direction angle of vectors. So here you have to find the angle theta, the direction angle. You are given for the vector the horizontal and vertical components already. So x is denoted by 2, y is denoted by 9. So you are given the horizontal and vertical component, and you need to find the angle and round it off to the nearest tenth of a degree. So the formula for direction angle that you will use will involve tan. We are going to trigonometry again. So tan of theta is the vertical component divided by horizontal. You know this from trigonometry. TOA. TOA means tan theta is opposite over adjacent. So opposite means the x value. So opposite is the x value, adjacent is the y value. So just put in the value, substitute, and you get your a as 2, b as 9. So you are just taking this like, a comma b. So put in the values, plug in. Now 9 divided by 2 will be fraction. This fraction can be converted to decimal, so it will be around 4.5. Take the calculator, use inverse trigonometry here. So what are we using? Inverse trigonometry. Always when you have to find angle, you use inverse trigonometry. So this is near about 77.5, and that's rounded off to the nearest tenth of a degree. You can do the graph also for the direction angle. So you can see, if you draw the vector 2 comma 9 on the coordinate plane and you measure the angle, it comes around 77.5. Okay, so that was your answer. Time for you to do another one. Here the direction angle of the vector needs to be found, and if you see carefully, if I compare with x comma y or I compare with a comma b, then the x component is negative 7, the y component is 2. You can plug in the value in the tan formula. Take inverse trigonometry. Here the angle is, the value is negative. So the angle also comes out to be negative. So it is negative 15.9 degrees. That's your answer. Now, this angle, if you want to convert into a positive angle, you can always do that. So for that, again, you are going to go to the graph, you're going to go to trigonometry. So the angle you had got was negative 15.9 degrees, which was this angle. Now, if you want to write this angle in terms of a positive angle, you have to take the anti-clockwise angle, remember. Okay, so if this is negative, it means it is clockwise direction. That's what you had here. So you convert it into a positive angle by subtracting from 180 degrees. So 180, this angle, the anti-clockwise angle, would be 180 minus this angle, 15.9. So that's your positive angle in rounded off to one decimal place. So final answer, you have to always give in a positive angle in the anti-clockwise direction. So you'll give it as 164.1 degrees. In a similar way, I want you to try this question and check your answer. I'm sure many of you would get the correct answer as C, 104.5 degrees. Do let me know in the comment section, how did you solve this question and did you get the correct answer or not? Let's now do an important word problem on applied vector operations. Let me read it for you. A soccer player runs forward at 7 meters per second and kicks a soccer ball with a velocity of 30 meters per second at an angle of 10 degree with the horizontal. What is the resultant speed and direction of the kick? So first steps first, when you do a word problem, you highlight the important information. You take it out from the question. You also mark the important things given and then decide what needs to be found. So you need to find the resultant speed and direction. So resultant means you are adding the vectors. So what are the two vectors given? One is having 7 meters per second, but it is running forward, means it is only in horizontal direction. So there's no vertical component. So if you want to write in component form, it will be just 7 with 0, because you are just running forward along horizontal. There's nothing on the vertical component. Second vector which is given is velocity, 30 meters per second. That's the magnitude. Direction is 10 degrees. So you can write 30 cos 10 degrees, 30 sine 10 degrees as the component. So two vectors you need to find resultant. So v1 plus v2. That's a fair enough idea of the question. Let's draw a diagram as well. So 7 meters per second, that is on the horizontal. This is the component of 30 meters per second velocity at an angle of 10 degrees. Now, as I told you, the first vector will be 7, 0. For writing the second vector, we'll use the component form, this one. So let's go to the next slide. So you use the component form, plug in the values. The magnitude is given to be 30 and the direction is 10. So just plug in, find your angles, and this will come on simplification in decimal form as this one. Now we have to find resultant, means we are going to add the two vectors. So when we add the algebraic vectors v1 and v2, we get the resultant velocity r, and you get it by adding the horizontal with horizontal, vertical with vertical. So if you see, 7 plus this would give you 36.5. However, adding 0 to this does not change it. So this is the resultant. And now we need to get its direction. So for direction, we need the angle, and for magnitude, we need the square root formula. So the resultant of the vector would be by magnitude formula. I hope you have not forgotten. So you take the x component square, y component square, which will come out to be nearly 36.9. And then for the angle, we'll use trigonometry and we'll go to tan. So you divide your y component with the x component. So 5.2 by this, take the inverse. Go to inverse trigonometry as we did for the previous questions, and for inverse trigonometry you will get the angle to be about 8.1. So that means the resultant velocity for this question comes out with a magnitude of 36.9 meters per second velocity and at a direction or an angle of 8.1 degrees with the horizontal. That's your answer. Okay, now try your question yourself in a very similar way and check your answers. So if you have done it well, correctly, with following all the steps that was shown in the last problem, then your correct answer would have come as D. Let me know in the comment section how many of you got D, and do solve this question in your notebooks with all the steps. Okay, so as promised, let's do some important questions from your textbook. I will be doing 6A for you and 6B you'll try yourself. Let's do 6A. So here you need to find the component form of the vector with the given magnitude and the direction angle. So if you see carefully, the magnitude is given, the direction or the angle is given. So we need to use absolute value cos theta, absolute value sine theta formula. We are resolving it along the x and the y component. So x comma y, this is how we are doing it. So let's plug in the value. Absolute value is 8, the magnitude is given, cos of the angle which is 45, sine of the angle which is 45. Now both of them have the same value, 1 over square root of 2. So you can just plug in, you would see that both components will be same. So now I want to convert this into a decimal form. So let's do that. So I'm going to divide 8 with square root of 2. So this will come out to be 5.656, 5.65. Now if you see carefully, we have to round it off to one decimal place. So this is near about 5.7, 5.7. So both are same, and yes, that's your correct answer. In a similar way, do this one. Look at the angle and solve. So it will be 24 cos 210, 24 sine 210. So this is same as 24. The value here is square root 3 by 2 with a negative sign. This is 24 minus 1 by 2. So this will come out to be negative 12 square root 3 and negative 12. This is your answer. Very, very simple yet important questions taken from your book. I hope you understood them, and if you have got your correct answers, do let me know in the comment section. So that brings us to the end of today's session. I hope you enjoyed watching the video and you understood the problems that we covered today. All of them were very, very important, and you'll surely get some questions in your exam from this topic. So that's all from my side. If you liked the video, do give it a thumbs up. Share it with your friends of grade 11 who will find it useful. And do let me know in the comment section what all correct answers you got. If you have any questions or queries, let me know. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.